Let's go through an AP problem, complete start to finish. This is the 2009 problem number 6. Now, one of the things about the problem number 6s from AP tests is they are the longer, what they're called investigative tasks. Basically, it means it's a longer free response question than some of the others. So your score on an AP test would get a little bit more weight for the problem 6s than some of the other categories. So the question says, a consumer organization was concerned that an automobile manufacturer was misleading customers by overstating the average fuel efficiency in miles per gallon of a certain car model. The model was advertised to get 27 mpg, so that's the advertisement of the claim. To investigate, researchers selected a random sample of 10 cars of that model. So we have a sample of 10, and it is random. Each car was then randomly assigned a different driver. Each car was driven for 5,000 miles. Total fuel consumption was used to compute MPG for that car. So they did 5,000 miles for every car, so that data actually isn't a useful number for calculating. It's just useful for letting you know how they ran their test. And their first question says, define the parameter of interest and state the null and alternative hypotheses. The parameter of interest is always going to be your mu or your p. Either you're finding an average or you're finding a proportion. And in this case, we're talking about an average. It says the average fuel efficiency right up here. So the keyword average gave that away. So we're going to define our mu. And the way we would do that is we would just say mu equals average fuel efficiency. And we would say in MPG. And you would also want to make sure that you mention that it is of the population, so of population of this type of car. And the reason you need to say all of this information is because the sample mean, x bar, is a little bit different. It only refers to the 10 cars in your sample. The population mean mu, the symbol right here, refers to the entire population. It's also an average, and it's a fuel efficiency measured in a certain unit. So all of that information needs to go into that definition. It needs to be pretty clear. The second part is, it says, state null and alternative hypotheses that the consumer organization is interested in testing. Well, we had a claim of 27 miles per gallon. So 27 miles per gallon is our null hypothesis. So our mu, and we don't have to redo any additional defining once we clarified what it is, mu equals 27. We can say our null and abbreviate that H0. And then our alternative is going to be that mu is something to 27. We have to decide if it's greater than, less than, or not equal. So a consumer organization was concerned that the manufacturer was misleading customers by overstating. So they're saying that the claim is too high, that the real average thus must be lower than the claim, lower than 27. So mu is less than 27 is how we'd write that. We look down, and the problem continues here. One condition for conducting a one-sample t-test in this situation is that the MPG measurements for the population of cars of this model should be normally distributed. However, the box plot and histogram shown below show that the distribution of the 10 sample values is skewed to the right. So there's a sample of 10, and it is right skewed. And we can see that this graph is very clearly right skewed because the tail is off to the right. Part B says, one possible statistic that measures skewness is the ratio of the mean over the median. Sample mean over sample median. And when we talk about skewness, we always talk about those two not being the same number. So what values, small, large, close to 1, might indicate that the population distribution is skewed to the right? And it's referring specifically to that statistic. If something is skewed to the right, We can always look at our median as being where half of the data occurs. And so let's assume we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values in this graph. 1, 2, 3, 4, 5. So the median is somewhere right in here. Whenever you have that long tail, it's going to pull the mean above the median. So the mean is actually going to get pulled this way. So the mean is going to be something a little bit bigger because of those high values up here. The mean is going to be something higher than the median. So if the median was, let's say, 25, the mean would probably be a little bit higher, let's say 26. The point is not that you get this particular number that I got. You would actually probably not want to write something like that or erase it if you did. It's that this value is larger than 1. If the mean is divided by the median and the mean is bigger, then you would say my statistic is greater than 1. And the reason that it's greater than 1 is because the mean is larger than the median when a graph is skewed to the right. If we jump into part C, it says even though the MPG values in the sample were skewed to the right, it is still possible that the population distribution of MPG values is normally distributed and that the skewness is just due to sampling variability. What that means in essence is we just happen to get an unlucky sample that looks skewed, but really the population could still be normal. Now to investigate this, they took 100 samples, each of size 10, from a normal distribution with the same mean and standard deviation as the original sample. So they made up their own distribution, and they did something similar to like a StatKey type of simulation where they pulled values from this normal curve and pulled 10 at a time and calculated the mean divided by the median. And this is what they got right here. The lowest one was around 0.95 and the highest one was around 1.05. So when they're just randomly doing this, it's not going to be super far off that 1.0, which 1.0 would represent the mean and median are exactly the same, and that usually means it's not a skewed graph. In the original sample, the value of sample mean divided by sample median was 1.03. And that would be right about here on this graph. Based on the value of 1.03 in the dot plot above, is it plausible that the original sample of 10 came from a normal population? Remember, all of the data values in here came from a normal population. Or do the simulated results suggest that the original population is really truly skewed to the right? Let's count up how many were as high or higher than 1.03. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 more. We have 14 values over here. So there are, out of 100, 14 of them are greater than the 1.03. So if we assume that the null is true, in this case the question being asked is this a normal distribution? We assume that it is a normal distribution. How likely are we to get results as high or higher than 1.03? Well, there's a 14% chance that that can happen. So when you get down to your explanation here, you don't need to say the null and alternative and all of those things because it doesn't ask you to pose a formal hypothesis. But what you do need to do is you need to say, yeah, 14%, that is usually too high of a probability to reject the null. So let's go ahead and answer this question here. If we had to write this out, I'd say we estimated a p-value for the probability that we would find a statistic as high or higher than our observed stat of 1.03. And that's assuming a normal distribution. Let's scroll this down here. 14% of the values are above 1.03, and we said 14 out of 100 here. So it seems very plausible that this could happen. So the answer to its question is yes, it is plausible that it's a normal curve. Next question, jumping down to D, says the table below shows summary statistics for MPG measurements for the original sample of 10 cars. And it has the minimum, maximum, and the full 5-number summary. Choosing only from the summary statistics in the table, define a formula for a different statistics that measures skewness. Now this question is a little bit more open-ended. We have to define a new way to measure skewness. To look for skewness, we're looking for a bunch of values being bunched up real close to each other on one of the sides. And in particular, it says if we are looking for skewed to the right, down below here it says what values might indicate the distribution is skewed to the right, we would expect values on the right side of this distribution here to be closer together, and we expect values over here to be more bunched up farther apart. So one way that we could potentially do this would be to take the first quartile and see how far away it is from the median. So our left side would be median minus quarter one. So median minus quarter one. And then on our right side we could say how far is quarter three from the median. So we could take quarter three minus the median over here. And using the same basic idea they used above, we could divide those values. And so the gap in here divided by the gap in here. If it's right skewed, that means that numbers on the right side are farther apart, meaning this bottom value should be bigger than this. So if this is our statistic, we would say if the denominator is bigger, the value is less than 1. So stat is less than 1. And that would be all you really need to say. So this is our stat, and you might want to say equals statistic. And AP always likes it when you write things out. So the more you clarify exactly what you're talking about is probably a better idea. So avoid the shortcuts.